All right, it's 5 p.m. Welcome everybody to this webinar about leveraging ChatGPT in KNIME workflows. My name is Roberto, and I'm a data scientist at KNIME. And before we start, and I also introduce my co-speaker, just a little more information about how you can ask questions during the webinar. We have a Q&A tab. Please type your questions in there. There is people in the KNIME team that can answer the questions while we are talking. And then at the end, of course, we also have a session about where you can guys ask a question, then we can answer them live. This being said, I will now like to stop sharing my screen, and I'd like to call on stage Diego Romero. He's going to be my host today. And Diego is working at NTT Data. He's a technology innovation manager. And thank you for being with us, Diego. And he's going to introduce us a little bit about what LLMs are in general, and give us a little bit of general understanding before we go into how we can leverage them in KNIME. Hey, Diego, please take it away.
Thank you, Roberto. Thank you, KNIME, for having me here. It's really a pleasure to introduce the question. Let me share my screen. So I think you are seeing now my screen, right?
Yes, we see them.
Okay, so just to give some context to LLM in general, large language model in general, inside generative AI, what we are calling LLM and generative AI is this artificial intelligence branch to aim to create new content. In this case, because we are here today is text, but we can generate many different types of data, not just for short text, but images, videos, audio, data with synthetic data, and for sure also code. But not just this. For example, we can have also models for generate music, also even model physics. So we have many models to generate new kind of data. We are here because all the job that we have done in the last not years but decades, and just to put you in context that for sure we have passed through at least 2 or 3 winters in the AI and also some springs in the AI. So, but something really new, or not really new, the application of methods like reinforcement learning and deep learning in the last year has allowed us to develop this kind of powerful models to, in this case, to generate text. And this is all the hype and all the interest from text generation, mainly with ChatGPT and all these text models, not just from OpenAI, but also from open source space with a lot of many models. In this case, more context, these large language models are generated using deep learning, and also inside after deep learning we are using also reinforcement learning and something very interesting technique that is called human feedback to create all the results from the models and in the train phase. So, but we have, as all of you knows, we have several applications for machine learning in general, and also deep learning, depending on the use case, depending on the techniques that we can apply. So we have many different AIs in that sense. So we need to select the correct one for the specific use case that we need to solve. Just for your also for your information, the level of interest that these new models are generating in the market is crazy. This is the last forecast. This is from Bloomberg. that the estimated size market for in 2032 is more than $1 trillion in business for these kind of models. But in just for 2027, in just 3 years, we are going to, or expected to generate almost $400 billion when we came from previous estimation less than 8 billion. So the increase on the expectations for this kind of application is huge. And all of these models, it's not new in the NLP arena. We have many different approaches in the previous years. All of these models and all of the approaches are still in place, and they are working perfectly fine for the use case. But something happened in the 2018 with the paper attention is all you need, and the publication of this paper about the new architecture called Transformer that allows us to increase a lot in the accuracy and in the capabilities of mainly in text generation for the new models. From this original model that is called BERT, we have the explosion of models is amazing. We are living what we call a Cambric explosion of large language models, and there are several. In this case, we have at least 3 main architectures with decoder only, decoder and encoder only. Sorry, decoder and encoder, and encoder only. And as one of this architecture, the decoder only is more focused on the text generation. This is all this branch of the LLMs. A huge number of large language models is being generating, and also is being fine-tuned and retrained to focus on specific tasks and specific use cases. Here is a kind of a graphic to show the size of the models. As you may see, the GPT-3, 3.5, and 4. They are not the biggest one. They are 175 billion parameters in size. And we have huge models like the ones from NLG from Microsoft, Palm from Google, even Gopher or Bloom. That is one of the biggest one from OpenSpace also. So we have many different large language models, and it's up to us to define the best one, or to detect and select the best one for our application. In this case, this is quite quick comparison of the main two architectures for BERT, and the other one is GPT. The GPT is the generative pre-trained transformer. So in this case, there are different methods to generate the text. In the first one with BERT, we have this mass language model that they try to estimate and give an estimation for the next word, taking account all the text. But in the other case, GPT is using what we call autoregressive architecture, that they are only taking into account the words in the previous sequence, in the previous text. So we are generating from left to right. So there are several differences in the two architectures, and it allows us to select the best one for the specific task. For example, for BERT is quite good in text classification, in image recognition, and question answering, because the model has all the context in all the text. But for text generation, it's better GPT, because it creates a more fluid text within with the previous context. In the left table, in the right table, we have some key facts about the two models. We have several, for example, talking about GPT, and this example with GPT-2, we have several different versions of GPT. So we have many different models regarding the layers that we have, the number of hidden layers that we have, the parameters that we're working on. For example, just for this comparison, BERT is just 110 million parameters, and GPT, the first version of GPT, is 1.5 billion parameters in just GPT is just 3 years ago. So it's the progression has been crazy, and the training data that all the models are using to be trained, it's the size of this training data is also huge. Regarding the GPT evolution from GPT-1 and GPT, in this case GPT 3.5 and GPT-4, that is more focused on instruct-based models, we can see a progression of at least, for example, the number of tokens that we can process in the context. The majority of the models has 2,000 tokens, but we have within OpenAI models, we have from 4,000 to 52,000, but we already have models like Claude that they have 100,000 tokens. So the size of the context that we can provide to the model to process and to make questions and to ask for text generation is quite interesting. We will see if the context, if the tokens, the number of tokens is going to increase a lot or not, or we are going to be more efficient in this context generation and context processing. But with this level of context, we have a lot of space to make many interesting applications. Some of the context that Roberto is going to use later in the demos with KNIME. For example, we have specific models to generate embeddings that they are the numerical representation of the text that we are processing to perform some tasks like search, clustering, recommendation, anomaly detection, and classification. So we can use these kind of models, and in this case, the ones from OpenAI called ADA, and with a high dimensionality because they are working with 1,500 dimensions in this embedding. So we can represent this text with high fidelity. For sure, every one of you has heard about prompts, about prompt engineering and prompts. This is the main configuration parameter for the models, and is where we can build the context, and we can provide the examples, and we can give the instructions for the models to perform the task that we want to from it. So it's mandatory to have a very good knowledge about how can we build the prompt, and how can we select the best example, for example, to do this few shot approach to provide these examples to the model. That is not for sure, it's not a fine-tuning for the model, but it's kind of a training or helping with the training to the model to perform the task. Also, as an evolution for the prompt, we have the messages in chat completions. So when we have this, when we are using this kind of models to for chat completion, we have messages from different roles. One role is a system, the other one is the user, and the other one is the assistant. So we can give a specific instructions in each of the roles, mainly on system and the users, because assistant is the response. And in the last version of the OpenAI, we have a very interesting functionality that is called function, that allows us to extract all the information to perform to automate the use of these models. For example, for calling APIs or for using, for example, something that is very common in KNIME, that is all the data in JSON structures. Talking about tokens, and just to be very quick on that, you need to be sure about what is the size of your prompt, because it depends a lot on the language that you are using. And we have here a kind of a comparison. We have the same text in different languages. We have different number of tokens. In English is the most optimized one, but for example, in this case, Spanish and French, for example, is more or less the same, but it's almost almost double the tokens. And for example, in Japanese is almost 3 times the number of tokens. So you need to be very careful about this tokens utilization, because the price is quite different, not just in the 3.5, but also in GPT-4, because it's not the same, the input tokens and also the output tokens. So you need to be very careful about tokens. Other parameters that is going to influence in the behavior of the models are temperature to control the randomness of the model, the top P to introduce also randomness in the generation, number of tokens that we are going to use in the response, the characters that we are going to use as stop characters to let the model know when we're going to stop, and presence penalty and frequency penalty to avoid or to indicate the model that you don't want to use specific sentences that they already included in the preview or in the original text. And the last one, I think, yes, the last one is all the new concepts from this version of OpenAI regarding plugins, function, and agents. I think in the demos that Roberto is going to at least to use some of the concept with agents, but they are these functionalities using along with automation are very powerful to define and to design these pipelines to make very complex applications. I have here some resources for you as a reference, and if you have any question, please let us know now and then at the end of the presentation. Thank you very much for your attention.
Thank you very much, Diego, for introducing us a little bit LLMs, what they are, and how models by OpenAI are working. Okay, so now I'm gonna share my screen, so we can move to how we can integrate or we can leverage this technology into KNIME Analytics platform. And there are mainly 2 ways we can leverage LLMs with KNIME. So the first option is within KNIME workflows, and for that, today we're gonna introduce a collection of use cases that we built using this technology and made them available as KNIME data apps. And the other option is for KNIME workflows, and this is something new that is coming in version 5.1. Version 5.1 is going to be released on July 19th, so stay tuned on this, but we will go back to this towards the end of the presentation. Let's first move to the options to use KNIME within, so LLMs within KNIME workflows. So the first case that I want to let's say introduce was a little bit of an experiment. Please keep in mind that this technology has evolved so much in a very short period of time, and so some use cases are probably less meaningful than they were when they were developed. And this specific use case about leveraging, for example, GPT-3 for question answering, probably today sounds a bit old, but that was the first experiment we did. And the goal here was to retrieve the top 10 questions from StackOverflows. Top here means the question that received over time the most votes by the community. If you're not familiar with what StackOverflow is, this is simply a large community forum where people ask questions about data science, programming, and tech in general. And here the goal was, can we blend this new technology that everybody's talking about within KNIME? And if we can we create a KNIME data app to compare human answer versus the answer provided by GPT-3? And so we started with experiment. So the first thing is what are the questions on StackOverflow? So for example, this is one of the question that enters the top 10 questions of all time in terms of upvotes by the community, and we can simply retrieve those questions by calling the API of StackOverflow. Very simple. A GET request gets you all these questions. This is the workflow that we built. So we originally had to obviously provide an API key. That's clear, right? That's how we authenticate into the service. We then select our model that we want to use. In this case, we chose GPT-3. And then we sent a post request to the model to obtain some answers connected to the question that we retrieved in the lower part of our workflow. We also, using the ID of the questions, we also retrieved the answer given by humans so that we can then join everything together and create a little dashboard that allow us to inspect it. And so that's actually how the final dashboard looks like. So as I said here, we select the model, we select GPT-3, whose model is TextDaVinci 003. And we have this nice little data app that allows us to get the answers to the top 10 questions of StackOverflow. So here you have it. And also, we retrieve some metadata. So who asked the question, who provided the human answer, and also we embedded the link here to the actual answer so that we could check if the model was accurate enough or was just a hype. So the answer here to the question, which JSON content type do I use? The answer by the model was the JSON content type you should use is application JSON. And if we check the human answer, you see exactly the same answer, except of course that the human answer is a bit more verbose because of course humans don't have number of tokens limitations. So this was a first experiment and worked well. And we thought, okay, why don't we start to expand a little bit this option and allowing user to ask their own questions. So not only questions connected to StackOverflow, but maybe something more, let's say, more generic or more philosophical. And so we ask, what is the meaning of life? And GPT-3 return a very mature and very mature answer, especially for the number of tokens that we ask, because we didn't want to spend too much money, to be honest. And next step, we thought, okay, whenever the new API for ChatGPT was finally released, was made available, we thought, okay, well, that would be cool now. Instead of using a model completion, we can now use a chat completion. So we can simulate a conversation with the model and create a little data app that allow us to communicate with the model. And this was just, as you can see, a simple experiment to show what we can do and also to give it a little bit of a KNIME look in terms of colors. Also, ChatGPT is much cheaper, so it was even a bigger incentive to try and build our solution. The first use case that we built would, let's say, actually make more sense to you, where we could use large language models, would be, for example, for the case of CV summarization. Imagine you have a HR department. They are usually loaded with CVs and applications. So how can they find an easy way to inspect this many different CVs and maybe cover letters in an effective way. Also consider that this CVs usually have different shapes, format. They try to be to be cool and attract people attention. So they don't have a predefined structure like maybe a simple text could have. So the idea would be to help the HR department to basically screen candidate CVs faster and maybe even allow them to search for relevant keywords. And the goal is to build an data app that does exactly that. So that allow us basically to produce summaries of the CVs, but also to retrieve candidate contacts, such as name and email, for example, and also to allow some keyword search. Okay, so how can we do that? This is not a trivial task. Think of, for example, as I mentioned in the previous slide, how complex it could be, let's say, if you want to train our own model to generate summaries, but also to understand some information that are included in the CVs. So now here, obviously, we are using the CV of Jack Sparrow and Alice in Wonderland. So it's, of course, this is a toy example in that sense. But there could be, for example, inline images, but there could also be skills and daily routine or activities that are not described by text, but rather by plots. So this would be an extra challenge to train your own model to, let's say, be able to identify this information and then summarize it. So this is how the workflow looks like that we develop. So without obviously having to use deep learning models or anything like that. And as you can probably imagine, the initial part, we provide the API key, we select the model, in this case, ChatGPT 3.5 Turbo. And then the one important part is that we use ChatGPT for text summarization, whereas for to extract the entities, so the people, the candidate names, we use name entity recognition, and for that, we thought, let's try to use traditional machine learning. And so here we have the section of the workflow that does exactly that. So this is cheaper because we don't have to pay for any additional service, and also works very well. So it's taking only a bunch of nodes to do that. And so we select the model, as I said, and how does the let's say the data app would look like? So imagine you are a HR head of HR. You want to upload your file, your CVs as a zip file. So you go there, you click select file, you select the zip. You then click refresh to propagate the file selection to the downstream nodes in your data app. And so what you end up is with such a view. So you have your candidates. So you also could extract some pictures, for example, if there is any. If there's no picture, we created a fake candidate and we place automatically this anonymous picture. We also want to, as I said, extract so not only the name but also the email in case we want to contact this person. And the next interesting part is that we would like, for example, to enable the search of keywords, right? So imagine we want to have a candidate that is able to that it has a degree or some kind of degree qualification. So we can put in the word degree in our keyword bar. And what we see is that we are able to highlight in our summaries that we saw below the word degree. We can select the row and automatically filter the candidate that has the basic had degrees. A degree, of course, in this case, is a degree in buccaneering and some other funny stuff for Jack Sparrow. But that's the idea. Imagine you have many different CVs. This will make the life of the HR department a little bit easier. Okay. The other use case that we thought we could build was the classic classification case, because we use often ChatGPT and it's a general purpose model, but how do we know how good it is actually for classification? Do we usually score this model? Usually when we use this model, we simply use it for inference. We don't take we don't use it, we don't score it, we just assume that it's working well. And so we thought, okay, why don't we actually try to see how it's behaving for those tasks? So for example, how does it classify sentiment, and how does it classify, for example, knowledge of previous X? This could be a product, it could be a service, knowledge of something that has happened in the past. And here the goal would be to, again, develop a 9 data app that is allowing us to score ChatGPT with labeled data in this case. Then using a precompiled or adjustable prompt for fast query. So let's say we don't want to type every time for those two specific cases a new prompt, unless we have to. But if we don't have to, then we can use a precompiled one. And then finally, when we are happy with the option of with the result that we have, then we can decide to apply to infer the label of our dataset to the entire dataset when we don't have, in fact, labels. So basically for simple inference. That's how the workflow look like. Again, the first part is always the same. We have an option to provide our key, API key, to select the model. And this is the part that changes compared to the previous use cases. So we have a section for scoring the model performance. So here we select a sample of our data set. And we select a type of learning we want to use. And here we decide we monitor basically the performance. So how good is the model performing? And we have assessed that by simple, common metrics for confusion metrics, a class, and overall accuracy. If we are happy with this performance, we can then finally use the entire data set and reuse the prompt that we tested here, because it gave us good results, and apply basically apply the model to the entire unlabeled data. So here we can do the inference. And so the first step in the workflow, as I said, is the choosing the type of learning and to monitor model performance. We decided to go two ways, to have two approaches. One is zero-shot learning, and the other one is few-shot learning. Zero-shot learning means we simply provide the prompt and we ask the model to produce a prediction. The few-shot learning, on the other hand, means we not only provide the prompt, basically asking to classify, to give a label to different rows, but we also provide actively some examples of what we mean. For example, in the case of a sentiment analysis, if we want to have a positive sentiment or negative sentiment or a neutral sentiment. Moreover, for each approach, we determine whether we want to use a precompiled prompt and edit an existing prompt or write our own prompt. So let's see. This is how the scoring, let's say, the scoring model performance section of the workflow looks like. So here we upload the file. We refresh, so we obtain basic information about this specific file. Obviously, we select here the column with text, and here the target column. So here, in this stage, we need to have a labeled dataset. Since this is done or used for testing, we can also select a sample. We don't need to, let's say, use the entire data we have, because remember, this is a pay service after all. And how we can, let's say, we can then select which approach we want is by tweaking the configuration in the lower part. So we can select, for example, zero-shot learning using a precompiled prompt. And as you can see here, in the case of sentiment classification, we just ask the model to classify the text in our dataset using the label 1 for positive, 2 for neutral, and 3 for negative. Now, what if we want to, for example, provide some actual examples or use few-shot learning? We can do this by selecting few-shot learning. And again, we use a precompiled prompt for sentiment in this case. And here you see the precompiled prompt. So here I provided some actual examples of what positive text is, what a negative text is, and what a negative sentiment is, and what a neutral sentiment is. Of course, you can modify this part or maybe add more example. I just add one per class. And the other option is that you don't use any precompiled prompt and you write your own, because you have, for example, a different use case, which is not sentiment, which is not classifying whether a text express knowledge or previous knowledge of a matter. And the second part, so once we upload the file and we decide the type of learning, is to actually score the model. And here, as you can see, we have a confusion metrics for the three different classes. We have a class statistic and overall statistics, and we achieve, for example, an overall accuracy of 71.43%, which it's in line, to be honest, with other research that we saw on the specific use case. But to be honest, it also performs a little bit worse than BERT, at least at least in our let's say in our tries. And the reason maybe it's simply because of the way the training of the model was done originally, and also, but on the other hand, we need to remember that if we want to use even a pre-trained BERT, which can be done also with KNIME nodes, then let's say the pre-training, so the training of the, let's say, the top layers however, require much more time. So this has the big advantage of being super fast in producing these results. And we can always, let's say, tweak the prompt and make it better and make it more accurate. So this result can also be motivated by the fact that maybe the prompt was not the best. It can be improved. And finally, we finally decide to apply our let's say our perfect combination of prompt to the entire data set that has no label. So here we upload the file that has no label, so it's tweets unlabeled. We select the column with the text that we want to produce a prediction for, and the result is this, let's say, this other section of the data app that tells us how many rows were successfully classified. In this case, I use a data set of 50 rows, so all of them were successfully classified, and you have a little bit of a visual inspection of how the data set was classified by the model. And of course, you can, most importantly, download these results and use it in a different or for further analysis. There was also a little bit of a funny and let's say an experiment that came, so that basically ended up with a book. And the question was, can GPT write textbooks? The finding was that you couldn't really, because it couldn't really follow a non-standard outline, or most importantly, couldn't really keep a consistent, let's say, style in the text. So, for example, at the same level of detail or style or building on previous argument to continue with the next. So, in the end, we decided to repurpose the goal, and we end up with a little encyclopedia of data science concepts that was written with human supervision, and it's basically a collection of things and concepts that every data scientist probably should know, or would be helpful if he or she knows. This, of course, was not done with a KNIME workflow, but it's just a concrete example that became an actual thing that you can download for free from the KNIME Press website. So important, what is the technology behind all these use cases? So far, as you can probably imagine by now, also because you saw the workflow at the very beginning, the KNIME Analytics platform version 4.7 or previous, we could access and basically call the models by a simple post request. So we create a JSON request body, we send it to the post request node, and finally, we basically parse the response with the JSON path node. And this can be used for completion, for embeddings, for edits, for image generation, for basically all the services that OpenAI offers. Now, what is the interesting or the fun part here? This technology has evolved so much, even in KNIME in the last month, that we are very happy to announce, maybe some of you already saw a conversation or post on social media, that from version 5.1, we're going to have dedicated nodes. So on July 19, you will be able to download version 5.1. Right now, it's only available as a nightly, so it's not completely stable. So be careful if you're using it in production. We shouldn't, in fact. But we now have dedicated nodes that do exactly, they cover some of the steps of, let's say, of what we saw in the traditional way of doing or consuming LLMs in previous KNIME versions. As you can see here, you have an OpenAI authenticator. You have to where you can basically pass your API keys. We have a connector to chat model, so basically to ChatGPT 3.5, and to also other LLM models, for example, for models to do completion and embeddings. And also, as I said here, the OpenAI embeddings connector is exactly what it does. So here you basically can access model for completion, embeddings, and chat. If you are, let's say, using KNIME in the organization, usually the pace of updating from one version to the other might sometimes a little bit slower. So if that is your case, then previous version than 5.1 will definitely, so using this approach will definitely work in those cases. As I said, those nodes are great, but there's not only those nodes, because in version 5.1, there is a whole extension. It's a KNIME AI extension that comes with a set of nodes, not only for OpenAI, which we already saw, so those ones, but also for open source models available on Hugging Face. So the same logic, you authenticate to the Hugging Face hub, you can connect to LLM models, you can then connect to, for example, to the option to, let's say, generate text or to create embeddings. And then once you connect and decide which model you want to use, you can then, for example, use some prompters to work with LLMs models or a chat model prompter. Here, the difference is that you can use the chat model prompter to simulate their actual conversation like you would do, for example, when you're using ChatGPT. And here, the LLM prompter is more for completion. So you can still simulate the conversation, but the idea is that you are basically letting the model complete your sentence. And we also have a very interesting section here, which is the vector stores and agents. We have two types of vector stores technologies. And if you're not familiar with the concept of vector stores are basically sort of containers, mega containers of embeddings, for example. Imagine you have some files, audio, text, or images, and you use the embeddings generated by OpenAI, by Hugging Face. You choose the model you want. So those embeddings are then stored in this space, in this container, and then this vector stores allow us to basically map those embeddings to your resources and do something with it. So they are extremely powerful and can be used in conjunction, especially when they are used in conjunction with the concept of agents. The concept of agent is something that also Diego already introduced or mentioned in the very beginning. They act as sort of intermediary entities between the user and the model, and can basically become our sort of assistants to, let's say, to complete specific tasks that we want them to do. So, for example, we could provide some specific embeddings or to a task that we want to solve, and we can retrieve it with this, and then ask the agent with the agent prompter node to produce an answer, complete the text, or do something for us in general. If you want to, let's say, export this extension, this is already available in the nightly version 5.1. So here you go, you can already start playing with it. But if you want to use the stable version, which we recommend, it's available on starting from July 19. And here is a little workflow example that can be used, let's say, with the nodes that we can build with the nodes that we just showed, that we're going to be included in the version 5.1. So as I said, the OpenAI Authenticator node serves the purpose of connecting to the service. Then we can basically create an OpenAI embedding connector. We basically access the models that create embeddings, in this case, text embedding ADA002. We then decide to pass this embedding to the vector store. As I said, this sort of container. In this case, we are using the vector store that contains YouTube transcripts for the KNIME L1 course. And important, on the upper branch, we have decided to use a chat model, so ChatGPT basically. What we do here is that we combine this information into a vector store to agent tool to basically allow our agent to provide answers in our conversation using the resources that we provided here. So this is going to become an agent that is more capable of providing answers that are meaningful for KNIME, for example. So if we want to sort of teach our agent to provide answers that are meaningful to build KNIME workflows, or to answer questions that are related to KNIME, this for example, could be a way of doing it. Obviously, the more information we provide, the more embedding, the more resources, the better the model that the agent can respond. And obviously, we also need to define the functions, so it needs to be clear that which function the model has to use, so has to behave as an agent. And here you see a little the result. So a conversation between a human, Adrian is one of our developers, and the AI, in this case, ChatGPT, that was providing answers to to the questions provided. And with this, we conclude the part of using LLMs within KNIME workflows, and now the part where we can use LLMs for KNIME workflows. And in fact, there is plenty of good news today, and also coming in version 5.1. We have a new dedicated extension, which is called KNIME AI Extension Labs. Remember, this is lab extension, which means that it's still actively being developed. And you can use this extension to ask questions to your AI assistant directly within KNIME Analytics platform. But also you can ask your AI assistant to build KNIME workflow for you in a matter of seconds. So once you install the extension, you will see here a little chat button. You can go here. You will log in into your KNIME Community Hub account with your KNIME Community Hub account, and then you can choose what you want to do. If you want to ask questions, or if you want the model to build something for you. And let me give you a little demo here. Let's assume we are here. So this is an analytics platform in the nightly version 5.1. So we go to our assistant and we say, and we ask first a question. So how do I read an Excel file, for example? And our assistant immediately gives us an answer, which is correct. It's the Excel reader node, which we can then drag and drop into our workflow. Okay, but what if we want to, for example, now let's say ask the assistant to build a workflow for us? Okay, let's do it. So we go to the build tab and we ask the model, help me build a workflow. Oops. Apologies. For churn prediction. Let's see what it gives us. And this is the result. I didn't do anything. The assistant automatically created the workflow for me, and it is actually pretty accurate. You may say, okay, maybe this node, it's not really fitting, but the idea of reading a CSV file, partitioning the data, and then train it maybe, for example, with a decision tree learner, and then apply the train model to our test data is actually pretty accurate. Of course, you need to, this is still in development, it's still a prototype, so there is a big disclaimer here. Use it, being aware of this, that this is still, being actively developed, but this really will help, or hopefully helps you build KNIME workflow even in zero time, and even especially if you don't know how to start, this should be a great help for you, we hope. Okay. This one we already covered. Okay, and so we come here to the summary before we go to the Q&A section. So what we have seen today, we learned what LLMs are and how they can be used. We also went through a couple of use cases using GPT-3 and ChatGPT to build KNIME data apps. We zoomed in on some of the technologies that we use to build those data apps, but also how we can now in the future build new KNIME workflows within KNIME AI extension. And we also had a little taste of the new extension, the KI, that allows us to interact with an artificial assistant to build KNIME workflows, or to answer question around KNIME. All the use case workflow that I showed today are available on the KNIME Community Hub at the link. You will receive the slides in the follow-up emails. The example workflow about the KNIME AI extension will be available after the software release. And stay tuned, because on July 19, you can have the KNIME Analytics Platform version 5.1 in a stable version, so you can go to the download site and start using it right away. And with this, I conclude our webinar, and I'm now happy to, I'm gonna stop sharing. We can now go through some of the questions if there is any. I will be answering questions, and also Diego can answer questions if there's any for him. So please, let's have a look. So there was
Roberto, we've answered all of the questions.
Okay, perfect.
And we are answering currently. I think a brand new one just came in, or there's some comments that are coming in, but everything else has basically been answered.
Okay, great. That's awesome. Thank you, guys. And this is the KNIME team being super efficient, not only in developing, but also in providing great answers right away. So if any of you has questions concerning, for example, the material, as I said, it will be shared in the follow-up email, both the slides and let's say, and the recording of today's session. So if you want to rewatch it, you can watch it there. Let me see if there is any other question that maybe we can still answer live. Yeah, I see that there's a question about the workflow being available on the KNIME Community Hub. They will. The use cases are already available, and those using the workflow using the KNIME AI extension will be available after the software release, so after July 19, which is basically a week. Okay, I see there is a question about how you exploit ChatGPT inside workflow for analysis of machine learning model or AI model and stuff like this. So here is, I think it really depends a bit on, first of all, I mean, this is always the case, right? They always depend a little bit on the task, but here there is additionally let's say the important part is also how we engineer the prompt. There is now a whole new trend about how you can correctly or more effectively engineer your prompt. So in our case, we provide some examples. So we took some basically some we had a look at a little bit of the research that has been done around this topic. We saw what other researchers more or less how they were designing their prompts, and we decided to adopt a similar approach. So first of all, that's why we adopted a few shot, and so a zero shot and a few shot learning. And then how we design the prompt, as I said, this is a little bit can vary, and that's why we have introduced in the data app the option for the user to, for example, modify the prompt, right? So not only to use a precompiled one, but also to, let's say, to modify it, to edit it, and send that one to the model. So you can finally score it. And important to score how the model is performing, of course, you need to have, if it's a classification task, a labeled data set. So you need to have a list, a few samples that are labeled, and to be able to provide some sort of metrics. So this is, I think, this is basically the same practice as for any other machine learning model. Nothing new here. The only big difference that you can try to do this with very few samples, right? You don't need to have millions of rows here because you're not training anything really. You're just basically using it to infer the prediction on a label data set. You evaluate the performance, and then you basically can replicate the process by modifying the prompt until you finally basically reach a level that you think it's satisfying. And at that point, you can automatically, with the data app, automatically apply that optimal prompt, let's say, to your actual data set that you want to classify, for which you don't have labels, so you cannot really assess the performance there. There you can only visually inspect what the model has done at the end. So that's how you could more or less, let's say, come around with this with evaluation of the model. And that's also what researchers have been doing recently to try to understand how good it is. And was the research that we saw, it was not surprising, in fact, for the researchers, that some trained models, as I said, BERT, for example, could achieve a higher accuracy on this specific task, because, well, there basically you are training the top layers of the model, especially if you do transfer learning, if you're using pre-trained BERT on the specific task. So you're basically allowing the model to, to learn on your specific task, which is, which is good because you're basically trying to generate predictions that are specific to your data set, not based on the training, generic training that the model has done. Basically, on the internet, that's the text that the technology that OpenAI provides is based on. So there you have always a trade-off between trying to use a a cost-effective and also resource-effective approach like this one, or trying to have maybe a more accurate approach with with your own model. So it's a little bit the usual the usual trade-off. Let's see if we have time for maybe one more question. I see there are many that have already been answered. There is a question, I think, what use cases have you seen or would you recommend for financial analysis with ChatGPT? I think somebody already provided a paper, which is great because I haven't worked in a specific use case in that sense. The important thing is that you also have to keep in mind is that, of course, how this data is being treated, right? So it's important that you go through the terms and conditions of the providers. I think as of today, if I'm not wrong, this changes so quickly. So please double check this information. It might be the case that the data that the user sends are no longer stored or no longer used to train the models further. But please double check this information because I might be wrong. And so it is a little bit in the sense, it's a different way you send your data to, or it's a different way you use your data in those models. But I haven't used it for a financial use case. For example, the use case about the CV summarization, if those were real people's CVs, maybe we should be a bit more careful, right? Maybe we shouldn't send people-centered data to a model, to an external model, let's say, regardless of if it's OpenAI or regardless of which is the provider. We should be careful in general with the aspect of data privacy and data governance. So that is something that the user needs to be aware of and not blindly use the model just because it's easy to access. So please keep this in mind. And let's see if there is any more question, any new question. I see here.
The main thing that I saw Roberto was asking
yes.
about the assistant. They were asking, how do you get access to that?
Right. Yes, that's a very good question. So, all right, let me again share the screen. Okay. So if you're talking about this assistant, there is an extension which is called KNIME AI Assistant Labs extension. So you have to have, first of all, KNIME version 5.1, which is currently in the nightly. So unless you download the nightly, you will have to wait until July 19 to be able to install it in the stable version. Whenever you have your KNIME Analytics platform in version 5.1, you can look for an extension like you do for any other extension and select the KNIME AI Assistant Lab, which also should be installed together with an KNIME Python developer extension. So then they have to come together in the installation. And once this is installed, this chat symbol will automatically appear here as you see it. And at that point, before you can use it, you are prompted. There is a link here that asks you to connect to authenticate into your KNIME Community Hub account. And then once you do that, like you do when you are when you usually connect to the KNIME Community Hub with your account, then this appears, and then you can switch very easily and smoothly from the QA tab to the build tab. It's probably much harder to explain than to use it. So if you're really, really curious and cannot wait any longer, well, just go have a try in the nightly version. Otherwise, next week you will be able to use it. And I think it's 6:01, so we should probably wrap it up. Thank you very much, everybody, for joining this webinar today. Thank you for all your questions. Thank you to Diego for providing us with this interesting introduction into the theory of LLMs in general, and to the KNIME team that helped with the Q&A in the background. With that, I would like to say goodbye to all of you and see you next time. Bye-bye.